In this lesson, we're going to continue to work with the concept of functions. Remember that a function is a relation with a particular criterion that says each x only gets to correspond to a single y value. All right, let's suppose that we have y equals 2x. This is a relation. Each x that I put in here, if I put in x as 1, I get y as 2. If I put in x as 3, I get y as 6. Now I could do this infinitely, and this would generate a set of ordered pairs. Is it a function? The answer is yes, because each time I put in an x, I get a different y value. So 1 is going to correspond to only 2. When that's the case, we might want to be able to tell that something is a function without having to test it in any way, and that can be denoted by a name change. F of x is equal to 2x. The name change tells you about the relation, and it tells you it is a function of x. Now, this is read just like it says up here, f of x, standing for function of x. You do not have to exclusively use letter f. The common letters, just common, are g, so there's g of x, and there's h of x. Those are just names of functions. And each one of these is in the place of letter y. Okay, so that is what function notation is. Now it can be very helpful notation, and it will be in upper level math. Whereas you used to have y equals, I'm going to make it easy, 2x. Now you might have f of x is 2x. Okay. In the old notation, if I said given x is 5, find y, you would say, okay, y is equal to 2x, y is equal to 2 times 5, y is equal to 10. In this notation, I would simply say find f of 5. So what I'm doing is saying when x takes on the value 5, what is the function's value? And you would substitute it in, you would then simplify, and you would get 10. Now I want you to compare this statement with this statement and see which one provides more information. This one tells you y is 10, but you have to look back up into the problem to see what the x was that corresponds to it. In function notation, you can see it right here. F of 5 is 10. The function acting on x equals 5 gives you y equals 10. So, in the old notation, you would have an ordered pair, x, y. In the new notation, you would have x, comma, f of x. In an old t-chart, you might have x, y. In a t-chart with function notation, you would have x, f of x. F of x is a new name for the y in the relationship. And sometimes in upper level math, instead of having the axes x and y, you would have the axes x and f of x. Now we're not going to use this exclusively now, but you will see us begin to use function notation or a function naming pattern for relations that are indeed functions. Let's look at some problems and what it asks us to do. Given the following function, find, and it says 3 things, f of -4, f of 0, and f of 5. All right, so I have f of x is 2x plus 1. That's my function. F of negative 4 is 2 times negative 4 plus 1. It is negative 8 plus 1. It is negative 7. F of negative 4 is negative 7. That means that when x is negative 4, y is negative 7. The next one, it says, what is f of 0? Well, it's going to be 2 times 0 plus 1, which is 0 plus 1. F of 0 is 1. When x is 0, y is 1. All right, the last one it asks us to do, it says find f of 5. All right, f of 5 is going to be 2 times 5 plus 1. That's 10 plus 1, which is 11. F of 5 is 11. So the number in the F parentheses is the X. The answer you get is the Y. So this is substitute in and simplify. Let's look at number 2. We have a function. It is called f of x is x squared plus 3. Let's find f of negative 4. That means negative 4 squared, use parentheses, plus 3. That is 16 plus 3, which is 19. F of negative 4 is 19. The next one, what is f of 0? Plug in 0. 0 squared plus 3. That's 0 plus 3, which is 3. F of 0 is 3. Final one, what's f of 2? Well, it is 2 squared plus 3, which is 4 plus 3, or 7. F of 2 is 7. They give us some x values and ask us to plug them into the function notation. Let's do a few others. This one has the function f of x is 2x. So finding f of negative 3, which is 2 times negative 3, f of negative 3 is negative 6. F of 0 is 2 times 0. F of 0 is 0. Last one, f of 3 is 2 times 3. F of 3 is 6. So the function might be very easy to evaluate. And our final one, they changed the name to h of x. H of x is 2x squared minus 5. Can we find h of negative 4? That's 2 times negative 4 squared minus 5. Use your order of operations, which says to, which says to square first. So it's 2 times 16 minus 5. 2 times 16 is 32 minus 5. So that gives me 27. A little more complicated than our last problem. If I do the next one, it says what's h of 0? Well, that's going to be 2 times 0 squared minus 5. 0 squared is 0. 2 times 0 is 0. And 0 minus 5 is negative 5. H of 0 is negative 5. Finally, if I do the last one, h of 1 is 2 times 1 squared minus 5. Exponents first, 2 times 1 minus 5. Multiplication, 2 minus 5. So h of 1 is -3. Okay, so that is function notation. It is plugging in the x's and calculating their corresponding y values.